Then we have talked about the basics, sensors, technologies, sampling systems. Now I would like to start with our TESTO 340. And later on, I would like to talk about our latest analyzer, the new TESTO 350. This is actually how it looks like. I guess many of you have it in use already or have seen it before. This is our TESTO 340. I will just take one instrument. This is how it looks like. This is the size of it. Yes, it's, we have the different buttons to operate the instruments. Here's the display. You can show up to 8 values at the same time. Here we have the condensate trap built in, but it's not an active condensate trap. It's just a regular condensate trap. And yes, the functionality depends, of course, on the ambient conditions. That means if you have 25 degrees ambient temperature, your dew point will be 25 degrees, and you will not be able to suck or to get more condensate out of the flue gas than the dew point of the ambient air. And here we have also removed the back part of the instrument, the cover, which gives you access to the sensors, the battery, and all the inner parts, which can be changed by the user. So basically, the TESTO 340 is a 4-gas analyzer. That means you cannot measure more than 4 gases simultaneously at the same time. The O2 sensor comes as standard. That's always equipped. And you can choose 3 different sensors. And one thing is, a second sensor must be fitted. That means if you just want to use the TESTO 340 as an oxygen analyzer, this does not work because it doesn't make sense. It's too expensive. There's cheaper instruments available. And this is why we said, okay, a second sensor beside O2 must be equipped. And the parameters which can be measured is CO, CO low, NO, NO low, SO2. Yes, those are the parameters. And depending on which slot or which sensors is equipped in which slot, we have one dilution system for slot number 2. That means every sensor which is equipped in this slot can be diluted by a factor of 5. That means if you have high CO readings or high NO readings and you would like to perform this measurement, and maybe the NO concentration is above the measuring range of the sensor, you can just put the NO sensor in slot number 2, and then you can dilute the reading with factor of 5. This is the single slot dilution. Or we have dilution of all sensors with factor of 2. And this can be chosen as well if you say, okay, 3 or 4 readings are very high or can be high during the measurement. You can use the analyzer in the overall dilution mode, and then all parameters or all sensors which are equipped in the analyzer will be diluted by factor of 2. Just protect the sensors. And because we don't use an active gas preparation unit, and we don't know what will happen after 2 or 3 or 4 hours of measurement, depending on your application and how much condensate will be in your flue gas. The limitation is less than 2 hours measurement duration. That means if you would like to do a long-term measurement, you can set up the analyzer, and you cannot perform a measurement longer than 2 hours, just to make sure you will have an accurate reading and everything is fine. And this is different with the TESTO 350. I will show you later, because there you have a chance to add on the internal gas preparation. As I showed before, the dilution of the sensors will take place with ambient air. As I said, we have the single sensor dilution for slot 2, or the dilution overall with factor of 2. You can perform the measurements even at high concentrations, and the sensor is not higher exposed as at low concentrations and obtains the maximum sensor lifetime. And you know, in this way, we have so-called switch-off limits of the different sensors in the instrument. And that means if you don't have the, because this dilution, I will go back, this here is standard. This comes with the instrument. And this single slot dilution, this is an option which has to be ordered. It's not coming as a standard. What happens if you don't have this functionality here and you say, okay, at 8,000 ppm CO, the sensor or the instrument should switch off. And this is what will happen. You can start the measurement, and as soon the CO reading reaches 8,000 ppm, the instrument will switch off, the sensors will be rinsed with fresh air, and then the analyzer will go on standby. You cannot continue the measurement. If you have the dilution at this single slot and you put the CO sensor inside, then you can say, okay, at 8,000 ppm, the automatic dilution should be switched on, and then you can continue your measurement. And only the CO sensor will be diluted by factor of 5. That means there will be only 400 ppm at the sensor, and you can continue your measurement without interruption. So this is one advantage for long-term measurements, or if you measure at an application where you don't know exactly how high the concentrations can be. Then we have also the condensate trap. There is one feature because there is a maximum level within this trap, and we have 2 electrodes which measure the level of the condensate within this trap. That means we have this automatic liquid level monitoring of the condensate trap. And you know, if you perform a 2-hour measurement, which is possible with the instrument, you put it on site, and it can be that you have a high amount of condensate in your flue gas, and you leave from site, and the instrument is still there and is performing the measurement. And in case a lot of condensate gets to the analyzer, there is a specific protection. If the maximum liquid level has been reached within this condensate trap, there's two LEDs inside, and then the condensate trap, it starts blinking red for a few minutes. And if you're still not on site, or if nobody's there and the analyzer continues the measurement, just to protect the internal gas path, the sensors, after 10 minutes blinking, the pump will stop automatically, just to protect the sensors, which helps to save costs, of course, because yes, sometimes, you know, I've seen different applications, especially in the US at gas engines. They have drop tubes, stainless steel drop tubes from the stack, and they have, you know, all kind of drop tubes. And the first thing is, if you connect the analyzer to such a drop tube, in the first few seconds, the analyzer does not suck in flue gas, it sucks in all the water of the drop tube, because it connects during the day or night time. You have a lot of water there, and just to protect the analyzer against this water, yes, we have this functionality to make sure everything is correct. One other feature is the automatic flow controlled gas pump. Some regulations, they say if you perform a long-term measurement, your gas flow should be within 10% over 2 or 3 hours, and you have to make sure that the analyzer is within this flow rate, because a change in the flow rate has also influence on the accuracy of the reading. And Some analyzers in the field, they have just a flow control device to make sure that the analyzer gets at least 1 or 2 liters per minute. And if there is a higher flow rate, it will exceed to the ambient. And what we have done is we have an automatic controlled pump inside. That means if you start the measurement and all of a sudden the underpressure or the pressure within the stack increases or decreases, we measure this inside of the instrument, and if there is an increase of the pressure in the stack, the pump reduces its flow, the power will be reduced, that you have a stable reading, or if the flow decreases, then the pump will stop it. So just according if you have overpressure or underpressure, the pump recognizes it and will keep the limit or the flow within 1 liter per minute, just to have a stable flow rate. And because of this functionality, we are also able to have a sampling hose up to 7.8 meters. The standard sample hose of our probes is 2.2 meters. This is just connected with the flue gas probe. It's 2.2 meters, and you're able to connect 2 extension pipes, which is 2.8 meters. You can just connect the next hose here and the third one up to 7.8 meters if necessary to perform your measurement. And even within this length, and if there's under or overpressure in the stack, we can make sure that the flow rate is constant at 1 liter per minute. Yes, then some features of the instrument at different applications. You know, if we are talking about stationary engines for different kind of applications, it can be a compressor station at pipelines, it can be a combined heat and power station producing heat and electricity, it can be a water pump station, whatever. And if you have to adjust the engine, it's very necessary to measure NO and NO2 separate, because especially at gas engines, the NO2 part can increase and decrease during operation very highly. And therefore, because you adjust the engine to your NOx reading, which is NO plus NO2, it's necessary to measure NO2 separate, because many users or operators, they just measure NO, and then according to the application, they can add a percentage of NO, which is related to the NO2 reading. You know, depending on the fuel, and if you have a small burner which is burning oil or gas all the time, it's no problem, because then you know your NO2 part is 2 or 5% of the NO. You can just add 5% to the NO2 reading, then you will have your NOx reading. If everything is stable and the fuel will not change, it's not a problem. But specifically at the gas engine, where the NO2 part can increase and decrease all the time, it's necessary to measure both separate to have a real NOx reading. Measurements even at high gas concentration, this is what we were talking about, the dilution system. If the engine is out of control and you have very high CO readings because your O2 controller is not working correctly, you can have CO concentrations up to 50,000 ppm, and this can destroy the sensor very fast, or at least it shortens the lifetime of the sensor. Then we have special engine probes. I will show you later on for this application. And then we have also the engine-specific parameters which needs to be measured within one instrument, like oxygen, CO, NO, and NO2 separate. And then, of course, the calculations like lambda or XSR can be performed within the analyzer. Then, if we are talking about burners and industrial combustion applications, with the analyzer, you can calculate parameters for the optimum adjustment, like the fuel-air ratio, efficiency, flue gas loss, everything can be calculated within the analyzer. Also here it can happen that you have very high CO readings if you don't know the system, or if the air-fuel ratio is wrong, to less oxygen for the combustion process. And of course, because of its rugged housing, you can use it also when you travel by plane, or because of the size. This is very convenient. Many service technicians, if they have to measure at different countries, they just put this in the baggage and nothing will happen to the analyzer because of its housing. It's very rugged and nothing will happen to the analyzer, and so this is convenient for them, the size. If we are talking about industrial emission measurement, spot measurements for up to 2 hours can be performed. That means within the analyzer we have 5 different measurement programs with, there is the duration of the measurement, there is the measurement rate, like a reading once a second or a reading every 10 seconds. They are predefined, the programs can be changed at any time, and therefore you can perform your measurement up to 2 hours, and all the data will be stored in the analyzer. And then, of course, with Bluetooth or USB connection, you can transfer all the reading online to a computer and perform the data, do your reports, whatever. Or you can hook up the analyzer with a notebook or with your computer, and then you can perform an online measurement, a real-time online measurement on site. For later on, you can do your calculations or your reports for your customers, whatever. A simultaneous differential measurement is also possible. That means if you do the flue gas measurement, you can just connect a pitot tube with the differential pressure plus and minus, and you can put it also into stack, and then you can measure the velocity simultaneously, and based on the stack diameter and the concentration of the flue gas, you can calculate volume flow and mass flow, and then you can report the data to the authority. At different measurement points within the plant. That means, because we don't use AC power for operation, we can operate the analyzer for up to 6 hours without AC power. It's very easy to take this little instrument or small instrument to different spots within the plant to perform the measurements, and you are not really dependent on AC power. And of course, the flexibility in the selection of sensors, because you can choose between CO, CO low, NO, NO low, NO2, SO2, oxygen. You can set up the instrument according to your application. And then we have the application gas turbine. Here the feature is the special NO low sensor for low concentration, as I mentioned before, because the limits are getting tighter and tighter and the NOx values going down. And with this low NOx sensor, you can perform measurements up to 10 ppm. At the same time, your CO readings at a turbine are also very low, but sometimes at the startup, or if the turbine doesn't perform correctly, you can have high CO readings, because the CO low measurement range is up to 500 ppm. But if you put the CO low range sensor in the instrument and you have the dilution system at the same time, you can extend the range up to 2,500 ppm. That means even at low concentrations, you can use the instrument, and if high concentrations occur during the measurement, the dilution will switch on automatically, and you can measure high concentrations even with the CO low sensor. and easy and accurate test adjustment possible by the user. Yes, if required, the instrument can be easily adjusted with calibration gas on site if required. Okay, so I would say this was the first part. Let's have a short break for 10-15 minutes, roundabout, and then I will continue with our tester 350. So thank you so far. Operation under toughest conditions because the housing is almost sealed. There is no chance for ambient air to get into the instrument, like acids, like SO2, whatever, to create corrosion within the analyzer. And we have also one feature, cost and time savings, due to the very easy access to all relevant service parts, bearing parts, and gas sensors. Okay, just talking about the control unit. Actually, this is how the analyzer box looks like, the new one. The control unit can be removed very easily. You can see all the readings of the analyzer box through the display of the control unit. You can show graphs in the display. I will show you later. You can also transfer data from the analyzer box to the control unit. And then you can take the control unit with you to the office, and then you can you can download the data to your notebook, to your PC, to evaluate the data and to do analysis. You can connect the control unit to the analyzer box either like this, it's clicked on, and then you can remove it easily, or you can also use a data bus cable. That means you can just connect the cable to the analyzer box and connect the cable to the control unit, and this can be up to 50 meters. Makes sense at big plants or where your sampling point is in a big difference to the point where you can do the adjustments. Or you can have Bluetooth connectivity. That means all the data will be transferred via, through Bluetooth. This is basically the control unit. Then we have the analyzer box itself. The analyzer box includes the gas sensors, the option Peltier gas preparation unit, all the pumps for the flue gas and for the ambient gas, and the condensate trap. And it can be operated through the control unit, or you can only operate the analyzer box with a PC or notebook without using the control unit. And you can save up to 250,000 measurements in this analyzer box. The new housing is also a very rugged design. I guess I need So there is optimized protection of the measurement instrument against shock and crushes here at the edges of the analyzer. You can see it's like an X shape, which helps to protect the analyzer if you put it on the floor. The special construction allows to safely turn the analyzer box while the control unit is fixed. That means this is also something we learned because the instrument or the display is very sensitive, and in the past with the former model it was only possible to carry the analyzer box this way. And now, because we figured out this could be a problem sometimes if you transport this analyzer box from side to side or within a plant, you can easily just move the control unit upside down. That means it's protected, and doesn't matter if you climb up a ladder and you scratch, nothing will happen to the control unit or to the display. It's protected. And yes, this is what I already displayed. Okay. Then the condensate trap is also very easy to remove from the analyzer box. It's almost an instrument itself. It's very easy to remove this condensate trap. You can either release the water manually, or you can, during a long-term measurement, you can just connect a little rubber hose to this condensate trap, and then the water remains automatically during the measurement, and you don't have to worry about the condensate. And you know, there is two functionalities. If you don't have a gas preparation inside, this condensate trap works like a condensate trap, like in the TESTO 340. It depends on the ambient temperature. Or if you have a Peltier chiller inside, a small pump will pump the condensate from the Peltier chiller into this container automatically. So there's two different functionalities. And if you're using a CO2 infrared module, and it can be that at the Peltier chiller, or if the pump is not working correctly, it can happen that condensate gets to the CO2 module, to the infrared module, and there is a protection filter like a water stop. That means if either the pump doesn't work correctly or something happened to the Peltier chiller and it seems like condensate is getting to the sensor, it will stop and block the gas path, that nothing will happen to the CO2 module. And then a new feature with the analyzer, the electronics of the instrument is separated from ambient air. That means we have two different chambers. Here, within the instrument, here is all the electronics like the power supply, like the pumps and everything, and they create a lot of heat. And in the past, we had also some, we could figure out that, you know, from the ambient air, if SO2 gets to the analyzer inside, that corrosion could happen to the circuit board. This was something in some application it could happen, and now the whole housing is sealed. The only thing is we have here a little, like a channel, and you can imagine here is a little fan sitting, and this fan sucks in the ambient air, and it stays only in this channel. There is no possibility for the ambient air to get inside to the instrument because it's separated. And here we have a heat exchanger built in, and here is also a small fan which circulates the hot air to the heat exchanger, and the ambient air becomes warm because of this heat exchanger and removes to the ambient air again. And therefore there is no access for the ambient air to get to the internal of the instrument. And here you can see, here's the inlet of the ambient air for the channel, and here's the outlet. And when you switch on the instrument, you can really feel that the air gets sucked in, and here the warm air gets blown out. So this is one new feature. The second feature is we have separate two chambers, one with the electronics and the pumps and everything, and the second chamber is for the sensors, and we are using a so-called EPEC. This is being used in computers. It's a special foam with a high isolation functionality, and therefore there is no chance that the hot air of the electronic parts gets to the chamber of the sensors, because it's thermally separated, and therefore we can really make sure that within this chamber the temperature keeps the same and there is no drift because of temperature changes, which helps, of course, to get a higher accuracy, or if you do a long-term measurement, that the readings keep stable. So this is two new features. This is what we were talking about before. We have the single dilution, and within the TESTO 350, you can choose different dilution factors like 2, 5, 10, 20, or 40. In the TESTO 340, it was just the factor of 5 and factor of 2 overall, and here you are able to choose different factors. And you can put CO, NO, SO2, or hydrocarbon sensor inside of this dilution slot. Sometimes hydrocarbons is necessary because a pellistor works with an internal combustion, and it requires at least 2% oxygen. And in some applications, like rich burn engines, you don't have that much oxygen in the flue gas. But if you would like to measure hydrocarbons, you can put it in the dilution slot. The sensor gets oxygen from ambient, and therefore you can measure hydrocarbons at rich burn applications. Okay. Yeah, this is just an overview, the 6 different slots within the analyzer, in which slot you can put which sensor, and slot number 6 is the dilution slot, which can be diluted, selectable, depending on the dilution factor. And then we have also dilution of all sensors with factor of 5. Same like TESTO 340, but here it's factor of 5 and not factor 2. This is also new. Choice of different country versions by the user. Basically, all the emission regulations, they are based on 3 different calculation bases. One is the German calculation, then we have the British calculation, and we have the US regulation calculation base. And based on those 3 calculation bases, you can choose different country versions. That means you can say, okay, I would like to measure according to German law. Then you can choose calculation German, and within German you can say, okay, I would like to have the analyzer in Spanish or English, whatever. You can choose different languages. And this is new, and this is important for companies which work in different countries when they send out their service technicians, that they can measure according to the local law. This wasn't possible before with our analyzers. And then this is also new, and this helps that you can measure with the instrument even if you don't know something about operational things of the analyzer. It's very easy. We have different applications inside of the analyzer, like burner application, turbine, engine, lean burn and rich burn, and we have customized. And depending on which application you're choosing, you will get the typical fuels. You will get precapitable order of the exhaust gas parameters in the display. That means only those parameters which make sense for this application will be shown in the analyzer as a default. Of course, you can add or remove different parameters at any time, but it's just a presetting of the analyzer. And we have useful instrument presettings, like at which point the dilution has to be switched on. I will show you as well later. But this is very helpful and makes it more easy to operate the instrument. That means at a gas turbine or at a turbine, you won't find coke or wood as a fuel, which doesn't make sense. So it's really specific for this application. And you can just choose this application, say, okay, start the measurement, and everything is all set, and you can start. And this is how it looks like. Example burner. If you choose burner, then you can say, okay, I would like to make a gas measurement, or gas with velocity, or gas with delta pressure, or only a draft measurement, depending on which choice. Then you can choose the fuel, natural gas, butane, propane, kerosene, doesn't matter. And then you can start the measurement. It's only 3 steps to get to the readings. And dependingly on the application, the analyzer will switch on the dilution at specific points. You don't have to worry about high concentrations. And yes. And this is also a nice function. If you don't have an NO2 sensor installed, the instrument will show you automatically the NO2 factor, which is set by you. If you say, okay, NO2 is 5% of NO, then it will appear in the display, and you will get NO, the NO2 portion, and the NOx reading in total. The same for the other applications like turbine. Here's an example. You choose turbine, which kind of gas, which kind of measurement. And here's one example of graphs. You can show also the graphs, and you will have a history over the past 2 or 3 hours, and you can see trends, whatever, in CO and NOx. And you can transfer those data easily to a software and do your reports. The same with customized application. This is just, you can do everything. It will include all fuels which are available, all kind of measurements, and there is just one presetting, O2 CO, depending on the sensors which are equipped, but you can do whatever. There is no automatic switch on of dilution. It's just a measurement according to your requirements. This might be interesting for you. We have different measurement programs in the analyzer, and one is called CTM 034. This is based on the US regulation. This is an additional test method which helps to use this kind of analyzer for official measurements. And you know, the CTM 034 has different phases, like there is a ramp up phase where the analyzer starts taking the reading until it's stable. Then we have a data phase, which is a specific time, like 15 minutes. And then we have a rinse phase where the sensors get rinsed. And this is defined in this regulation or in this test method. And we have put this test method into the analyzer. And you can choose, you know, different phases, like, okay, I have a ramp-up phase of 10 or 15 minutes, and the sample rate should be 1 second. Then I have a data phase of 30 minutes, and the sample rate should be 1 minute. And then we have a rinse phase, which is 5 minutes, and yeah, the data rate is 1 second again. And this can be set up to the analyzer, and then the analyzer performs this measurement according to your presettings, and then you can show this measurement as an official measurement. And one requirement as well is that the mean values they have to be calculated for the ramp-up phase, for the data phase, and also you have to show the rinse phase. And at the end, you have to calculate a mean value over all mean values, depending on how many cycles you are measuring. I'm not sure if it's interesting for you, but more and more countries are following the US regulation, and this becomes a more important topic. So we have covered this as well. This functionality here, you can, like in the TESTO 340, you can connect a pitot tube to measure the velocity parallel to the flue gas. But this is even more accurate because every pressure sensor, they're prone to drift depending on changing the ambient temperature. That means if the temperature increases or decreases, the pressure sensor starts also to decrease and increase its reading. It's yes, it's very how should I say, dependent on the ambient temperature, and therefore we are offering a functionality which is called automatically zero the delta pressure sensor. That means if you would like to do a mass flow concentration calculation or a volume-based calculation over 2 or 3 hours, you can put this functionality in the analyzer, and then the delta pressure sensor will be re-zeroed every 60 seconds for 1 second. That means even if it starts to drift after 1 minute, the analyzer zeroes the sensor again to get down, and then you will have a stable reading over the duration of the measurement. And this is different to the TESTO 340 because this functionality we don't have in the TESTO 340. This is just the difference between a tuning instrument and a compliance instrument. Of course, the LCD display can show graphs as one feature, and then we have also one functionality. We are providing the software Easy Mission, where you can do online measurements, where you can do different kinds of calculations, of reports, whatever. And here you have additionally the functionality to do a cross sensitivity calibration of each sensor. That means if you would like to do a cross sensor calibration to the CO sensor, you're able to put NO and SO2 to the analyzer and then to calibrate the sensor according to its cross sensitivity to get an even more accurate reading. So this is one functionality which doesn't come as standard with the analyzer, but with the software you can increase the accuracy or the cross interference a lot more if you have the crossing gases in your stack in the flue gas. And this is just some possibilities how to connect the analyzer to the notebook or to the computer. One way is to use USB between notebook and the control unit. And here you can connect a TESTO data bus cable, which can be up to 800 meters. Or you can just connect the analyzer box to the notebook with USB cable. Or if you're having a bus system, which is also possible, you can connect the control unit with USB to the notebook, and then you can connect up to 16 analyzer boxes in a row, which are daisy chained. And in some application, this is very helpful. In the US, we have many applications where they have to measure the NOx concentration within an SCR reactor. And this SCR reactor is as big as a big house. It's up to 10 stairs high. And they have to measure at between 5 and 20 different points at the same time the NOx concentration, just to see if the ammonia injection is taking place correctly or if they inject too much ammonia or too less ammonia. And this is very helpful for them to measure simultaneously NOx at different points across the reactor. Or we can connect the control unit with Bluetooth to the notebook and having the same system. Or we have a specific USB controller for a bus system which replaces the control unit. If you don't want to use the control unit, you can just use this data bus controller, and then you can hook up a bus system without the control unit. Then we have different ways to communicate, like Bluetooth between notebook, control unit, analyzer, or between control unit and analyzer. We can print out the data with infrared or with Bluetooth, or we can just connect the analyzer box with the notebook with Bluetooth connection. And this can be up to 100 meters in the so-called free field within a plant where you have steel or thick walls, whatever. It can be less than 100 meters, but in the free field it can be up to 100 meters, the communication between notebook and analyzer box. This is just specification, but you have it in your brochure, the measuring ranges, the extensions. I don't want to go through those slides. This is just some functionalities of the software Easy Emission. You can show the readings as a table or as a graph. You can do a real-time measurement with Bluetooth or USB. Yeah, you can hook up a bus system. You can create an Excel sheet or a PDF with your measurements. You can create your own report with your logo on it, and then you can calculate mean values and use this as a report. So there's a lot of possibilities with the software Easy Emission. And then, yes, it's almost like the Testo 340. We have different functionalities for industrial burners, like the helpful instrument presettings save time, because only the fuel and the display according to the application will be shown. We have also this dilution system, which can be switched on automatically or by the user. Yes. The service parts, this is something I would like to show you as well. You have really easy access to all the service parts. Here is the different pumps sitting, the rechargeable battery. You have really easy access. All the hoses are connected to different connectors, which are provided with numbers, so that if you remove the hoses, that just to make sure you connect it to the right connector again, which will be mentioned in the manual. But this is very easy because it's only 5 or 6 connectors. And then you can remove the pump, you can clean it in the field. You don't have to send the analyzer for service. And the same in the sensor chamber. This is only equipped with 2 sensors, but it's very easy to remove the sensor and to replace it with a rechargeable, with a spare sensor in the field. You don't have to send it back to service. Emission control, application, compliance testing. Of course, we have this high precision NOx and CO measurement with special sensors for the low ranges with a resolution of 0.1 ppm. And you know, for compliance testing, even if you have very low concentrations, it's necessary to use the gas preparation unit just to have stable and comparable conditions from site to site or within a day if you perform a long-term measurement, just to make sure everything is at norm standards. Yes, with the PTFE hose for NO2 and SO2 readings, that there is no absorption taking place, but this has already been taken care of because all our probes are already coming with this Teflon hose, so there is no standard hose anymore or a Teflon hose. It comes as standard with this hose. We have this, this flow controlled pump, 1 liter per minute plus minus 0.1 liter accuracy. And you know, we can measure from minus 300 bar up to 50 millibar overpressure and keep the 1 liter per minute stable. And it doesn't matter if you have a long hose, like up to 16 meter, or if it's just a standard probe, the reading will be stable within minus 300 and plus 50 millibar. You can also calibrate the analyzer by yourself in the field, like the Tester 340. And yes, of course, for the accurate reading, the sensor chamber is thermally separated from all the other electronics just to keep the temperature stable, that no drifts can be caused. What new, we have also one signal inlet. That means you can connect an FID analyzer or any other instrument which provides an analog signal, and you can just connect it to the analyzer. We have here a small connector, and then you can put this 4 to 20 milliamp signal here to the analyzer, and then you can add this additional external signal in the control unit, and you can do a measurement which we cannot provide yet, so that you have everything within one report or within one measurement. And of course, this long-term stable mass flow measurements with the automatically zeroed delta pressure sensor, just to make sure that the sensor doesn't drift and you have an accurate and stable velocity measurement over a long term. Yes, thermal processes like glass industry, like cement, like brickstone, whatever, steel industry. We have this long-term measurements. You can, set up a program with a measurement phase and a rinsing phase, and then you can measure up to days, weeks, months, whatever, keeping this rinsing phases in the instrument. Exhaust and differential measurement we were talking about. The high concentrations with our dilution system. This is also something we mentioned or we were talking about. And you can see many features will be repeated again for the different applications because it makes sense at gas turbines, at thermal processes, whatever. And industrial standard instrument function for more security because of those cooling loops and that no ambient air with soot or particulate or acids can get into the instrument to destroy the circuit board. So this is also prevented now and nothing will happen. And then, of course, application gas turbines, this high accurate NOx reading with the low ranges, 0.1 ppm resolution. Also the combination of CO low and NO low. Then you have to, or you can calibrate the analyzer by yourself according to your regulation. And yes, because of the ruggedness and the different thermal separated chambers, just to make sure even low concentrations can be measured very accurate.